Hi dear students, let us continue our discussion related to the fundamentals of physics, and today we have to discuss the topics related to mechanical properties of solids and fluids. So now, before entering into the topic, we first know about the matter, because here we are going to deal with the physical states of the matter, right? And this is a very familiar definition for you, right? Matter. Define matter. How we can define matter? Anything which has definite mass and occupies space is considered to be matter. Whether it may be visible or invisible, that is not a matter. Okay. Matter means anything around us which has definite mass and occupies some space. We are considering it as a matter, and we are going to have three physical states of the matter: solid, liquid, and gas. One more very simple and well-known question for you people, that is to make the differences between solids, liquids, and gaseous states. Right? Just take it as an assignment question. List out the differences between solids, liquids, and gaseous state. We are going to have the fourth state also, plasma state, but which requires a huge amount of heat energy, and it is not possible to reach that much of high temperature. So we are just simply neglecting that plasma state, and we are going to study only the three physical states of matter: solids, liquids, and gases. You can observe the plasma states in stars, where we are going to have a huge amount of heat energy, because of which the gases will be in the ionized form. Gases will be in the ionized form, and make the difference between solids, liquids, and gases. That is enough. And for that comparisons, you may think about the shape, the size, isn't it? So solids, they are going to have definite shape and size. What about the liquids? Size is nothing but the volume. Liquids, they are going to have definite volume, but they don't have definite shape. Gases, neither the definite shape nor the volume. We can think about the arrangement of the molecules, isn't it? So in solids, they are closely packed. That means the intermolecular separation is very much less in case of solids. So if you think of liquids compared to solids, the intermolecular separation is very much more, but compared to gases, it is somewhat less. And in case of gases, the intermolecular distance is very much high. Then we can think of that intermolecular force. In solids, the molecules are lying very close to each other, so intermolecular force of attraction is very much high. In case of liquids, it is moderate. In case of gases, it is very weak. Then we can think of the compressibility. Solids are, we can say, they are incompressible. Liquids, they can be compressed. Gases, they can be highly compressed. And we can think of its densities also. Solids, they are highly denser. Liquids, they are moderately denser. And gases, they are very less denser. So like this, we can compare different properties of solids, liquids, and gases. Why we need that knowledge means here we are discussing about the mechanical properties of solids and fluids. We know very well about solids, but what about fluids means? The materials which can flow, they are considered to be fluids. That means the liquids and gases collectively, they are called as fluids. Liquids and gases collectively, we are calling them as a fluid. So, what do you mean by this mechanical properties? See, these physical states of matter can exhibit several kind of properties, and here we are just focusing on how they will behave because of the application of the external forces on them. how solids will behave under the applied forces, how the fluids will behave under the applied forces. We are calling those properties as a mechanical properties. How the physical state of the matter is behaving due to the applied forces. Due to the applied forces, that is, we are studying under the heading mechanical properties of solids and fluids. What about fluids? Collectively, the liquids and gases, they are called as fluids which can flow, which can have the nature of flowing. So, here we have the general definition of the mechanical properties. Mechanical properties are physical properties that a material exhibits upon the application of force. How they are going to behave with respect to the applied force. How solids are going to behave. We have to study some important properties. How the fluids are going to behave because of the applied external force, or they may exert some forces, and all those concepts we are going to study in this concepts. So now, let us first focus about solids. So here there is a very much closer by the intermolecular force is very much high, so they have definite size and shape. So let us consider, if we have a solid object, let us consider this chart. Obviously it is a solid. If I am going to apply some force on it, it is not changing its size and shape, then it is considered to be rigid body. It must be considered as a rigid body. That means the bodies which does not undergo any deformation. Deformation means they have to change their size or shape. If they are not at all changing their size and shape, even if we apply the external force, then they are said to be rigid bodies. No doubt they are solids only. Okay. So rigid body, an object having definite size, shape, and having zero deformation. Even though if we apply the force, it should not change its size and shape. Such objects they are called as, or such bodies they are called as rigid body. So now only I have taken an example of the practice, but it is not rigid because if we apply more force, it is going to change its shape and size. Isn't it? That means in practical there is no perfect rigid body. There is no perfect rigid body because by applying huge amount of force, we can change the size and shape. So, if the deformation is negligible, if deformation is very much less, such objects are considered to be rigid bodies. And now, here we are talking about deformation. When we can expect a deformation? See, here I am going to consider an object, spring here we have. So now, it has the definite shape and size, isn't it? So, if we apply some external force, we can say now it has been deformed. That means there may be change in size, there may be change in shape, or simply we can say there is change in its dimensions. There will be change in its dimension. So, what is cause for the deformation? That is nothing but the applied external force. So, that applied external force which brings a deformation is called deforming force. ಯಾವ ಫೋರ್ಸ್ ಡಿಫಾರ್ಮೇಷನ್ ಅಂದ್ರೆ ಶೇಪ್ ನ ಅಥವಾ ಸೈಜ್ ನ ಚೇಂಜ್ ಮಾಡ್ತಾ ಇದೆನೋ ದಟ್ ಫೋರ್ಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ deforming force. Yes, so here the applied force is called as deforming force. Look at the definition. Deforming force. It is the external force when applied on a body. It is the external force when applied on a body. Changes its dimension. That means the size may be changed, the shape may be changed, the length, whatever the dimensions are going to get changed, and body is said to be deformed because of that applied external force. If the dimensions were changed, then the body is said to be deformed. Such a force which brings deformation in the body is called deforming force. It is called a deforming force. That's very important to observe. See, I am going to apply external force. What we are observing? Yes, now we can say the body is deformed because of applied external force. Now I am going to remove the applied external force. Just I am removing that applied external force. What we are observing here? Yes, carefully, please observe the things. I am applying the external force. We can call it as a deforming force, and now I am removing the deforming force. So I am not pushing it upwards, right? Just I am removing the external force. So now there is one more force in the body which brings the body back to its original dimensions. Isn't it? See, now we have original size and shape, deformed. Now I am removing deforming force. It is regaining its initial size and shape. For regaining the initial size and shape also, it requires some force, and that force is called as restoring force. What we are calling that force as a restoring force. What it is going to restore? It is restoring the initial size and shape. That means it is restoring its original state, or it is restoring its original dimensions. Then how we can easily define restoring force? Can we give the definition of restoring force? Yes, it is very simple. Restoring force, it is the force which brings body back to its original dimensions after removal of deforming force. Now deforming force na remove ಮಾಡಿದ ತಕ್ಷಣ ಅದರ ಒರಿಜಿನಲ್ ಸ್ಟೇಟ್ಗೆ ಅದು ವಾಪಸ್ ಹೋಗುತ್ತಲ್ಲ. Now the force existing with the body is called as restoring force. So with the help of deforming force and restoring force, we have to understand the properties exhibited by the body, that is elasticity as well as plasticity. What are elastic bodies and what are plastic bodies? They are also dependent on this deforming force as well as restoring force. If the body regains its original state after removal of the deforming force by its property, that is called elasticity. The property is called as elasticity. If it is not regaining its initial state even after removal of the deforming force, whatever the change happened is permanent. Such bodies are said to be plastic bodies. Such bodies are said to be plastic bodies. Yes, let us move on to the definitions of elasticity as well as plasticity. Elasticity. Okay. The property of a body due to which body regains its original size shape when deforming force is removed. So after removal of the deforming force, if the body regains its original state, then the property is said to be the elasticity. The property of the body to regain its original state after removal of the deforming force, we are calling that property as the elasticity. Okay, so the bodies which has the property of elasticity, they are called elastic bodies. You can have the examples of rubber, steel, and etc. Steel is also elastic material. So if we are going to compare the rubber and steel, steel is more elastic than rubber. Can get the reason why and how while we are discussing that in the classes. Okay, rubber and steel both are examples for elastic materials, and steel is more elastic than rubber. And we must know the reason why we are giving that kind of statement, because we can stretch the rubber easily and it can be stretched for greater extent. But with the same force, we can not stretch the steel, and we are going to think rubber is more elastic in general way. But in particular, steel is more elastic than rubber. That we can discuss in the classes. Okay. Now, some of the particles which does not regain their original state or initial state even after removal of the deforming force. ಅಂದ್ರೆ ನಾವು ಅಪ್ಲೈ ಮಾಡಿದಂತಹ ಡಿಫಾರ್ಮಿಂಗ್ ಫೋರ್ಸ್ ನ ರಿಮೂವ್ ಮಾಡಿದ್ರು ಸಹ ಅದರ ಹಿಂದಿನ ಅಥವಾ ಮುಂಚಿನ ಸ್ಥಿತಿಗೆ ಅದು ವಾಪಸ್ ಹೋಗ್ತಾ ಇಲ್ಲ. ವಾಟ್ ಎವರ್ ದ ಚೇಂಜ್ ಹ್ಯಾಸ್ ಬೀನ್ ಅಕರ್ಡ್ ದಟ್ ವಿಲ್ ಬಿ ಪರ್ಮನೆಂಟ್. ದಟ್ ವಿಲ್ ಬಿ ಪರ್ಮನೆಂಟ್. ಆ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್ ಇಂದ ಏನು ಬದಲಾವಣೆ ಆಗಿದೆನೋ ಅದು ಹಾಗೆ ಇರ್ತಾ ಇದೆ. ಅದು ತನ್ನ ಮುಂಚಿನ ಅಥವಾ ಹಿಂದಿನ ಸ್ಥಿತಿಗೆ ಪುನಃ ವಾಪಸ್ ಹೋಗ್ತಾ ಇಲ್ಲ. Such a property of a body is called plasticity, and those materials which exhibit that property, they are called plastic bodies. Yes, the definition of plasticity: the property of a body due to which body does not regains its original size and shape when deforming force is removed. It does not regains its original size and shape even after removal of the applied deforming force. Such bodies, they are called plastic bodies, and here we can have the example, that is mud, wax. So wax, if you are going to press that by applying some force, and after removing that applied force, it doesn't change its shape. So such bodies are said to be plastic bodies. Now, related to the elastic materials, we have to think of the stress as well as the strain. These are the important definition we have to understand. Okay, so we came to know that if it is an elastic body, it is going to have that restoring force, isn't it? If we measure that the restoring force per unit area, the restoring force associated with a particular area, that restoring force acting per unit area is considered to be stress. It is considered to be stress. It is very important. See, the restoring force developed per unit area when deforming force is applied. So this is related to the elastic materials. When we apply the deforming force, if they are elastic, there will be restoring force. If we measure that the restoring force per unit area, then it is considered to be stress. That is the stress of that material. So we can have the formula: stress is equals to force by area, where this force is restoring force and we are measuring that with respect to that area. So we have the formula: stress equals to restoring force per unit area. Then think of its SI. We already know that the force is measured in terms of the newtons and area is measured in terms of meter square. So the SI unit of stress is Newton per meter square. Newton per meter square. Now, in the same way, if we apply the deforming force, there may be change in the length, there may be change in the area. That means the dimensions will be changed. If we are going to measure how much change has been occurred with respect to the application of the deforming force, we have to move on to the concept of strain, where the strain is considered to be the ratio of the change in dimensions to the original dimensions. It is the ratio of change in dimensions to the original dimension. So this stress and the strain, they are related to the elastic behavior of the objects. Very important. Strain. Let us consider, because of application of some force, there is an object. Initially its length is L, and we are applying some deforming force, and because of that elastic behavior, it will have that restoring force, and the deforming force and restoring force, they are equal. Okay, so if it is compared to elastic, they are equal. If you want to measure stress, then we can think of the restoring force acting per unit area. Then what about strain? Here the dimension, let us consider the length will be changes. The change in length here, let us consider as delta. So L is the initial length, delta L is the change in length due to the applied external force. Then how to get strain value? Just we have to take the ratio of the change in dimensions to the original dimension. Likewise for area, for length, then for volume, we are going to have the particular strain. We have different kinds of strain, that is depends on the dimensions we are measuring. So now the things will be clear while we are discussing in detail in classroom. Nothing to worry about. The stress and strain, where we are going to learn these things in depth, the types of stress and the types of strain. Just now, please remember the definitions. What is stress and what is strain? And let us just focus on the relation between the stress and the strain. See, if the stress is more, obviously there will be more strain. So what this is I am going to say, observe it. I am applying greater deforming force. Now ಜಾಸ್ತಿ deforming force apply ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಅದರ restoring force ಸಹ ಏನಾಗುತ್ತೆ? ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಯಾಕೆ ಅಂದ್ರೆ ನಾವು ಜಾಸ್ತಿ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ದೀವಿ ಅಂದ್ರೆ ಜಾಸ್ತಿ ಚೇಂಜ್ ಆಗಿರುತ್ತೆ, ಬದಲಾವಣೆ ಜಾಸ್ತಿ ಆಗಿದೆ. ಅದನ್ನ ವಾಪಸ್ ಅದರ ಹಿಂದಿನ ಸ್ಥಿತಿಗೆ ತಗೊಂಡು ಹೋಗಬೇಕು ಅಂದ್ರೆ ರಿಸ್ಟೋರಿಂಗ್ ಫೋರ್ಸ್ ಸಹ ಏನಾಗಿರುತ್ತೆ? ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಸೊ ದಟ್ ರಿಸ್ಟೋರಿಂಗ್ ಫೋರ್ಸ್ ಪರ್ ಯೂನಿಟ್ ಏರಿಯಾ, ದಟ್ ಈಸ್ stress becomes more. Stress becomes more if applied deforming force is more. In the same way, if deforming force is more, the change in dimension is more. If the change in dimension is more, then the numerator is more, means the strain also becomes more. Now, ಸ್ವಲ್ಪ force ಹಾಕಿದ್ದೀವಿ, deforming force ಕಡಿಮೆ ಇದೆ, restoring force per unit area stress ಕಡಿಮೆ ಆಗುತ್ತೆ. ಅದೇ ರೀತಿ elongation ಸಹ ಏನಾಗುತ್ತೆ? ಕಡಿಮೆ ಆಗುತ್ತೆ. ಈ elongation ಯಾವ್ದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿದೆ? That we are going to measure the ratio of change in length to the original length in terms of strain, and that restoring force per unit area is associated with stress. Then we are concluding that if deforming force is more, stress becomes more and strain also becomes more. If deforming force is less, restoring force per unit area, stress becomes less and elongation is also less. That means the strain also becomes less. So we can conclude with some limitation, that is elastic limit. That means the object should not lose its elastic behavior. That means within elastic limit. Within an elastic limit, we can relate stress and strain, and that law is called Hooke's law. Hooke's law states that within elastic limit, stress is directly proportional to strain. Within elastic limit, stress is directly proportional to strain. Please focus on this portion. Directly proportional. Because if deforming force is more, ಜಾಸ್ತಿ elongation ಆಗಿದೆ spring, ಅದು restore ಆಗಲಿಕ್ಕೆ force ಏನಾಗುತ್ತೆ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಹಾಗಾದ್ರೆ force pulling area stress becomes more. Then strain, change in dimension ಜಾಸ್ತಿ ಆಗಿದೆ ಅಂದ್ರೆ strain ಸಹ ಏನಾಯ್ತು ಜಾಸ್ತಿ ಆಗಿದೆ. Stress ಜಾಸ್ತಿ ಆದಾಗ strain ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ. In case if stress becomes less, the strain is also less. That means they are directly proportional. ಒಂದಕ್ಕೊಂದು ನೇರವಾಗಿ ಅವಲಂಬನೆ ಹೊಂದಿದ್ದಾವೆ. ಸ್ಟ್ರೆಸ್ ಜಾಸ್ತಿ ಆಗಿದೆ, ಸ್ಟ್ರೈನ್ ಜಾಸ್ತಿ ಆಗಿದೆ. ಸ್ಟ್ರೆಸ್ ಕಡಿಮೆ ಆಗಿದೆ, ಸ್ಟ್ರೈನ್ ಸಹ ಕಡಿಮೆ ಆಗಿದೆ. So Huxley relates the stress and strain, and there is some limitation that is called within elastic limit. That means the material should not lose its elastic property. Within that limit, the stress is directly proportional to strain, and you can also have the mathematical form. Stress is equals to K into strain. By removing the proportionality, STRES, so stress is directly proportional to strain. This is by the statement of Huxley, and that proportionality sign will be replaced by multiplying with some constant, that is modulus of elasticity. So K is a constant for modulus of elasticity. So Huxley relates the stress and strain within elastic limit, and they are directly proportional, and this is the mathematical form of the Huxley. Stress is equals to K into strain, where K is a constant for modulus of elasticity. So this is all about the mechanical properties of solids. Now we have to think of the mechanical properties of fluids. That means how the liquids as well as the gases, they are going to behave because of the application of the external force. And there we are going to consider the fluid statics as well as the fluid dynamics. Fluid statics and fluid dynamics. Fluid statics means we have to consider the fluid at rest. So if we are going to think of the mechanical properties of fluids, we have to consider fluid statics and fluid dynamics, where that static, that is nothing but to get rest, dynamics to be in motion. So here the mechanical properties exhibited by the fluids when they are at rest. We are going to study here there is fluid statics. If the fluids are allowed to flow, we are going to study the mechanical properties of such fluids under fluid dynamics. Statics means to be at rest, dynamics means to be in motion. So fluids, the gases and the liquids collectively they are called as fluids. So now we can discuss these things in detail, so don't worry. Just let us think of the fluid thrust or pressure. Okay, fluid thrust. Or we can call it as pressure. In order to understand this, let us have the container. It is filled with water starts to flow out. Water starts to flow out. If you want to close that hole, what happens? That water will gushes out if there is more pressure. That means the fluids are exerting the force on the walls of the container. Notice, ಈ whole milk of fluids ಹೊರಗಡೆ ಬರ್ತಾರೆ. ನಾವು ಇದನ್ನು ಕ್ಲೋಸ್ ಮಾಡಲಿಕ್ಕೆ we have to apply some opposite force. ತೀರಾ ಜಾಸ್ತಿ ಪ್ರೆಷರ್ ಇಟ್ಟು ಮಾಡ್ತಾರೆ. ಸ್ವಲ್ಪ ಎಲ್ಲರೂ ಓಪನ್ ಇದ್ದ ತಕ್ಷಣ ಆ ನೀರು ಅಲ್ಲಿಂದ ಏನಾಗುತ್ತೆ ಹೊರಗಡೆ ಚಿಲ್ ಮಾಡ್ತದೆ. ಸೊ ನಾವೀಗ ಟ್ಯಾಪ್ ನ ಕ್ಲೋಸ್ ಮಾಡಿ ಟ್ರೈ ಮಾಡ್ತೀವಿ ಅನ್ಕೊಳ್ಳಿ. ನೀರು ಜೋರಾಗಿ ಬರ್ತಾ ಇದ್ರೆ ಟ್ಯಾಪ್ ನ ಕ್ಲೋಸ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೋಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ನೀರೆಲ್ಲ ಏನಾಗ್ಬಿಡುತ್ತೆ ಚಿಮ್ ಬಿಡುತ್ತೆ. ಕರೆಕ್ಟ್ ತಾನೆ? ಅಂದ್ರೆ ಪ್ರೆಷರ್ ಏನಾಗ್ತಾ ಇದೆ ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ. ಸೊ ಈ ಕೇಸಲ್ಲಿ ನಮ್ಗೆ ಏನು ಗೊತ್ತಾಗ್ತಾ ಇದೆ ಅಂದ್ರೆ the liquid is exerting normal force on the walls of the container. If we measure this normal force per normal force exerted by the fluid at rest on the surface in contact with it is called fluid thrust. The total normal force exerted by a fluid at rest on the surface in contact with it. If we measure this fluid thrust per unit area of that surface, then it will become fluid pressure. Fluid thrust means the entire normal force exerted by the fluid which is at rest on the surface in contact with it. Fluid pressure means that total normal force must be measured per unit area. So, in fluid statics, we are going to study the Pascal's law, the applications of Pascal's law, the hydrostatic paradox, the pressure and atmospheric pressure concepts. In fluid dynamics, we are going to concentrate on the type of the flow of the fluid, that is streamline or turbulent. We have to think of the critical speed. Here we are going to learn the Bernoulli's principle, Torricelli's law, and we are going to study the concepts of viscosity as well as the surface tension. So, the mechanical properties of solids and fluids. Please go through the fundamentals. They are very helpful for better